No, you don't square it. How do I get rid of the radical out of the bottom when I'm rationalizing?
You could fraction.
You fraction, what type of fraction?
Like 1/3
They're appropriate.
or 3/3.
How about
Opposite.
radical 3 over radical 3? Because when I times the radical by itself, what happens to the radical? It goes away because I end up getting this. Up top, I'm going to get 5 radical 3, and on bottom, I'm going to get 2 radical 9, because 3 times 3 is 9. Does 9 have a square root? Yeah, 3. So now I get, up top stays 5 radical 3, and the bottom becomes 2 times 3. What's 2 times 3?
6.
And that is how I can rationalize the denominator.
Oh wow, that's cool.
Okay? And that's how I would keep my final answer. Now, what happens if it's written this way? This is a little bit of a different look. 2 over the cube root of 5. What do I do there?
Gonna put 3 radical 5 and 2 in front of 3 radical 5.
Okay, almost. This is a little strange because technically I need to do it this way. I need to multiply by the cube root of 5 squared. Okay? And because there's a reason for this. What is, and here's why. Do you see how this has a 3 on the outside?
Yeah.
So how many 5s do I need?
3.
3. So I only have 1 here, so I have to have 2 there. That's the easiest way to remember that. So that I can take the cube root of 5, okay, or of 5 times 5 times 5, which is 125, okay? So then up top, I get this, 2 the cube root of 5 squared, and on bottom, now that I have 3 5s, I can take the cube, which would just give me 5, okay? Now, they're going to make you square this 5 that's inside of here. And so you get 2 the cube root of 25 over 5 as your final solution. You need to leave it in that form. Don't plug it in your calculator. What's wrong?
Parker's just slow.
Oh, okay. Okay, try this one. Rationalizing a numerator. Okay, rationalizing a numerator. Rationalizing a numerator. Radical 5 minus radical 7 over 9. How do I rationalize a numerator? If it tells you to. What would I do?
Subtract them.
Not, I can't subtract them. They don't have the same insides.
Would you multiply by the opposite of the numerator?
Yeah, I would multiply by the opposite, Lindsay, yes. So I'm going to multiply by radical 5 plus radical 7 and radical 5 plus radical 7. Now I know we don't like radicals in the denominator spot, but because it's telling us specifically to rationalize the numerator, that's what we're doing. So there will be radicals in the denominator spot on this problem. Now, when that happens, you end up getting radical 5. It's like foiling, yes? Remember how to foil? So I end up getting radical 5 times radical 5. So it's just squared like this. And then I get plus radical 7 times radical 5. Then I get minus radical 7 times radical 5. And then I get minus radical 7 squared. Now, this part here and this part here cancel because one's positive and one's negative. Okay? This cancels with that, leaving me with 5. This and this cancel, leaving me with -7. On the bottom, I have 9 times radical 5 plus radical 7 right now. What is 5 minus 7?
2. Negative.
Negative, good. -2. So my final solution is -2, 9 times radical 5 plus radical 7. Tonight on your homework, I should see a bunch of work.
Okay, why are we foiling?
We're foiling because we were rationalizing the denominator and there's the numerator, and there's 2 portions to the numerator. So then I have to take the opposite sign so that the middles will cancel. Okay? And so because I have this as 1 unit and this is 1 unit, it's like foiling. It's like saying X and Y or whatever. And so I have to foil that way so that I can solve. Okay, writing exponential and radical forms and then simplifying with rational exponents is the last two things we're going to work on. Yes.
How big is our quiz going to be? How long?
I don't know, like 15 problems, 10 to 15. Some of the stuff we did is very easy.
Josh said it was homework.
Okay?
True. I did my homework.
I did my homework and I still didn't.
Writing exponential. Writing exponential and radical forms. Okay. So on this one, let's say I have radical 3. I want that turned into something with an exponent. How do you turn that into an exponent? We did this last year. It's going to involve fractional exponents. What number does this radical technically represent? Yes, a square, right, Lindsay? Okay. So, whatever this radical represents becomes the denominator of a fraction. There is no exponent here, so it's a 1. And here, that's a squared. So that's how you change something from exponential to radical form. You kind of just have to know it.
So basically, we had a 3 on it, it'd be 3 over 2.
Yes, correct. So Lindsay said if the 3 has a 3 right here, then this fraction becomes 3 seconds, and that's correct.
We just have questions.
Questions like this? Okay, try this one. Try this one. Radical 3xy to the 5th. How do I change that into exponential form?
Good question. Put question mark next to it.
What does this represent again?
Square.
Square, so what number?
2.
2. So that's on the bottom of my fraction. What's on top of my fraction?
5.
Good. So all you have to do is put it all in parentheses like this. Just keep it that way and say to the 5 seconds.
That's it.
That's it.
We just have 15 questions of this.
What about this one? X squared plus y squared to the 3 seconds. This time, they want you to change it into radical form. This is a curveball. This represents the square, so I know I'm taking the square root of this.
So it's the square root of x squared plus y squared and then 3.
And then cubed. Yes, Lindsay.
Wait, can you explain that?
That's exactly it. She said it is the square root, because this is what represents that, of this whole thing cubed.
Oh, that's it?
That's it. Okay. How about this one? 2y to the 3/4. This one's a little bit trickier. Z to the 1/4. Okay. Now, here's what you gotta look at. You gotta look at what these exponents are. Does the 2 have an exponent with it? No. So it stays on the outside of the radical. Do these fractional exponents have the same denominator? Yes. So what is my radical that I'm taking? 4. The fourth root. Taking the fourth root. And then I have y, and what would y be raised to?
Y.
To the third. And then I have z, and it's technically being raised to the first. So I can write it, or I don't have to write it. Yeah. And that's how you would write that one. So
What
take
if
it.
the denominators are different?
If the denominators are different, then you're going to have 2 separate radicals multiplied together.
Are we going to do that?
No.
Okay, cool.
And then last type of problem we want to look at is this. What happens if I have a to the negative 3 seconds? A to the negative 3 seconds. First of all, my question would be this. Can you have a negative exponent? So what do you have to start with? You put it under 1. So I have 1 over a to the 3 seconds. Now, what is my radical?
-2.
2, good. So it's the square root of a cubed. Okay. And then one more thing and we are done. Simplifying with rational exponents.
What is that, Josh? Something shows on our table first. It's coupons.
Okay, simplifying rational exponents. Here we go. Let's say I have parentheses negative 32 to the negative 4/5. Okay. Okay. So before I flip all this to the bottom, I can do that first because I have a negative exponent. I can do that first. Or I can flip it into radical form first, which is probably smarter because it will give me smaller numbers to work with eventually. So if I were to put this in radical form, what would I be doing? Like I did over here. What root are you taking? Yes, I'm taking the 5th root of negative 32. Is that a possibility in the first place? Can you take the 5th root of a negative number? Yes. Okay. Technically, this is in parentheses because it's raised to what power?
Wait, the 5th power?
Yeah, to what power? -4. It's raised to -4. So the 5 goes with the radical, the -4 goes out here. Is there a 5th root of negative 32? You can plug this in your calculator. I'll tell you how. Okay, so if you go to, on your calculator, if you go to the button that says math, press math. Okay, actually let's do this. Before you press math, press 5, then press math, and go down to number 5. You see where it has that X in front of the radical? Okay, press enter. Now put negative 32 on the inside and press enter. -2.
Whoa.
Okay, so I end up getting this.
Even number though?
This is lit.
I end up getting -2 to the -4. Now what do I know I have to do from here?
But isn't that an even number?
Put it under 1. No?
32?
This power. It's about the power, not about the radical. It's not about the number. Okay. So then I put it under 1 and I get -2 to the 4th. What is -2 to the 4th? It is some work, yes. It's what? Negative. It's, no it's not. It's positive. Positive 16, right?
Hey, why is
No.
it just negative?
Oh, it is negative, and here's why.
Oh, 4.
Because technically it's 2 to the 4th and then times -1.
That sucks.
Okay. Because it wasn't like this. If it had parentheses around it like that, then it would be.
Okay.
That's why. A little tricky order of operations, that's all. Oh no, it is like this. It should be 16. Okay. Boom. Now try this one. Lots of examples. That's what's nice about this book. let's try the cube root of the square root of 125. Okay. Does 125 have a square root?
Yes. It was like 5 we decided.
125 has a square root?
No.
No, it's 11.180.
It doesn't.
Okay, but I do know that 125 can be broken down into 25 times 5, and 25 is 5 times 5, like that, correct? So it's technically 5 cubed. Yes? Okay?
Really?
Yes, it's real. So what I can do is this. Our radical rules yesterday that we talked about is if I have a radical and a radical, I can combine them by doing what? What do you do? It's like if you have a power to a power. Yes, Lindsay, you multiply. So this is a 3 and this is a, what is 3 times 2? So I'm taking the 6th root of 125, and I know that 125 is 5 cubed. Now, I got a 2 because it's square. Okay. Now from there, I can turn that into a fraction exponent. What fraction exponent happens when I have 3 on the inside and 6 on the outside? 3 over 6. Does that reduce to what? To 1/2, like this, yes?
Correct.
5 to the 1/2. And so then 5 to the 1/2 would transfer back into what radical? What? The square root of 5.
I'm so lost.
Okay? Those are some of the harder ones you're going to be doing. But that is what your homework is over tonight. Those 4 things. Rationalizing the denominator. Rationalizing the numerator if they tell you to. Writing exponential and radical forms. And simplifying with rational exponents.
I'll teach you the regular class.
Yeah.